All right. So welcome, as I said, my name is Severin Dellsperger. Yeah, I'm a teacher, researcher, network engineer at the Ost University. So I don't talk a lot more about me. I want to talk a little bit about the university. So OST University stands for Eastern Switzerland University of Applied Science. And so we are the merger of three University of Applied Science based in St. Gallen, Buchs, and Rapperswil. And arguably, the campus in Rapperswil is the most beautiful one in whole Switzerland. So I know that the campus is very well known to a lot of you, since probably you did your CCI workshops there a few years ago. So let's zoom in a little bit and talk a little bit about the institute I'm working for. So I'm with the Institute for Network and Security, and we have three main pillars. So obviously, it's network. We also have a strong focus on cloud and cybersecurity. And if you zoom a little bit in on network, obviously, since we are doing applied research, we want to build the networks of the future. And I'm convinced, or we are convinced, that to build like the autonomous network at some point, we need to get data from the network. And so everything what is on our roadmap topics and is kind of or have to do with network observability, right? To do all the fancy stuff. And today I will talk a little bit about intent-based network combined with SRv6 and how we establish end-to-end traffic steering. So hands up, who is familiar with the intent-based networking principles? That is very good, very good. Who knows about segment routing and especially SRv6? Okay, still many hands, so this is cool because I only have like 1 or 2 slides. Let's start with the current situation. If you want to connect a network, a client network with a server network, and we don't want to follow the shortest IGP path, so then a network engineer or network admin has to configure some traffic engineering or traffic steering policy, probably on one router or more than one router. So let's take it simple. And so in today's network, we have some challenges which arise if we obviously have to configure these traffic engineering policies. Obviously, the network engineer has to have some domain knowledge. I don't think that my mom is able to do a traffic engineering policy. And so the concept is all obviously configuration heavy, and it has, I would say, one major drawback, that it's very, very difficult to bring this application awareness into our system. So traffic engineering policies based on different apps is kind of complicated. And so I would say it's fair to say that the user needs in the end are not fulfilled. And so we ask ourselves, so how can we address these challenges we found out and optimize the traffic steering for end users and their applications? And so with that, I'm going to talk a little bit about intent-based networking. So I'm not using any marketing slides. I'm using RFC 9315, which was written mainly by Alexander Clem. And there, I'm glad actually Damien put it on the slides. We also talk about declarative. So actually what we want to build with an intent-based network is that we have an intent which defines the goals or the outcomes in a purely declarative manner. And so we are focusing on what should happen in the network and not how. So again, we want to kind of define the aim, network do that and that, but not how it should do. And obviously, if you take a look at this cycle here, a user kind of has to express the intent, and the intent can actually be everything, but in our case, it's a traffic engineering intent. And then this intent has to be somehow translated into a system which then can automate the network. And obviously, since network can change, we have to monitor the network continuously. And if an intent drift occurs, if something changes so that the intent isn't fulfilled anymore, we have to trigger the actions, the corrective actions, so that the intent is fulfilled again. And so, SRv6, as said, so is a source-based data plane implementation. And so in our case, we have different instructions, which are called segments in the packet header. So in SRv6, since we're using the IPv6 data plane, the segments are IPv6 addresses are part of it. And each segment indicates a specific action. So this can mean forward a packet based on the shortest path or shortest ECMP path to the node where the prefix was announced, or forward it to a firewall or to any other service. So we're talking about topological as well as service segments. And importantly, the path is predetermined or can be predetermined by the source, since the source can add all the instructions to the packet header, and then the packet is flowing along the path it is intended. And obviously, with that, we have advanced traffic engineering capabilities, so we really can steer the packet through the network, which is on the path don't have to be the shortest IGP path. And so, how can we leverage intent-based networking and SRv6 to address these challenges? So, our idea was that we give the end user, in our case, a system administrator or a system developer, which has probably no knowledge about the network, a tool so that the user can express the intent. So, for example, I want to have a low latency path for my trading app, and it configures it on the end client, and there is some magic happening which adds some segments, so the segment list to the IPv6 packet for the trading app, and it flows through the path from client to server, and probably vice versa, via the path which in this case is the lowest, or which fulfills this low latency path. So we built a proof of concept, and actually I took out a lot of complexity of it. So on the left side, we can see the system administrator, in this case, configures the intent. So we're using Linux virtual machine with a little Go application. And this, as soon as the application is started, it takes the intent and it sends a request to the intent-based system, right? So this request includes the intent, the source and destination address, obviously, and information about which service. In our case, TCP ports, which we're using to identify the application. Then some magic happens. So the calculation based on the intent is done by the intent-based system, and it responds back, hey, please, if you want to use or for your intent, please encapsulate your packets with this segment. And for doing the encapsulation, we're using eBPF. And so we add all the segments directly to the application traffic. And SRv6 will ensure that the packets follow the intended path from client to server. So obviously, that we can calculate these paths in the intent-based systems, we need data, right? And so for our use cases, we configured the routers to send the link state information via BMP. So we're using BGP-LS into BMP and then get all the data about the network topology in the intent-based system. And we also get the streaming telemetry information. In our case, we're using YangPush, since we have Cisco devices, Cisco model-driven telemetry. And so the intent-based system can calculate the different paths with the information we get. So how does it look? So the first step in our case is obviously to talk to or tell the application which intents we have. So we can observe here, in this case, we want to go to a web server on port 80, and we have different intents. I will talk about that more detail, or I'll give you more details about that in a minute. So then the second step, as soon as the application, which on the client side is called Hawk-Wing, is started, it sends this path request with the intent to the Hawk-Eye intent-based system. So the Hawkeye is our controller. It takes the information, and based on the information we get, we can calculate the most optimal path. And in the fourth step, we're sending back a path result. And obviously in the path result, we are mentioning all the segments which have to be encoded in or encapsulated in the fifth step. So what do we have? As soon as the application is sending traffic, we can add the SRh to it, and we send it to the network, and segment routing will ensure that it gets to the server on the correct path. But obviously, we had to build a closed loop system, so we have to get the updates all the time. So the network is sending updates to the Hawkeye controller, and based on that, we trigger some recalculation. So for example, if we have a path, low latency path from A to B, and on one link we have like an increasing delay, it is possible that we have to change the path. So we have figured out a few, based on interviews and some industry requirements, we have created a so-called intent portfolio. So what are we able to do? Obviously, we can do what is already in the IGP, so we can do low latency, low packet loss, low jitter. But then we also have additional use cases, which I think are very difficult to do if you don't have streaming telemetry. So we can do low utilization, low bandwidth, high bandwidth. And also we have some more sophisticated use cases like service function chaining. So we can find the best services from A to B. So for example, if you want to go from client to server, and there should be a firewall and IDS system in the path, so we can find the best one based on the cost you're mentioning, low delay, low packet loss, whatever you want. And also we figured out that we can use flex algo to do only calculations based on a subgraph of the whole topology, which is also quite nice. Something I want to mention in addition is that it's also possible to have constraints. So what you could do with this solution is that you can say, okay, please use like the lowest utilized path, but still ensure that the delay is smaller than 50 milliseconds. So this is possible. And I think here we have a very sophisticated solution, and I will demonstrate that in a moment. So I was actually not so let me switch to the, come on, where is the, okay. So we have our topology, we can see it here, and I choose the low latency use case or intent in this case, and so we want to connect host A with host B in this use case. And as soon as we have our application not involved, we obviously take the shortest IGP path. So we see the red path goes from host A over XR2 to host B and includes these paths which have huge delay attached. And obviously, we'll see that in a moment, this is a problem, but first check how this turns out. So I will switch now to the host, and I do an MTR, and we'll see, okay, on port 80, it takes me around about 30 or 27 milliseconds to go from host A to host B, which is actually not so bad, but based on the low latency, we can find a better one. If you take a look into the Wireshark, obviously this is just, right now this is just plain IPv6 routing, so we won't find an additional header there. So everything works quite fine, but it's probably not the best path. So let's figure out how we can find a better one. So here we can see that all the metrics get collected. We can visualize them in Grafana. And if you take a closer look, we will see XR2, for example, has different interfaces with different delays. And if you take a closer look, we can observe that there is one link which has around about 10 milliseconds of delay attached. All right, so let's go back and find a better path based on our low latency intent. So obviously, if we still want to go from host A to host B, but we can find a better path, so we're doing a shortest path calculation, in our case, just based on the delay metric. So we go to XR1, then we have to go to XR2 since there is no better path. And we can observe that there is like the link between XR2 and XR6 is huge, so we want to avoid it. So instead, sending it directly to XR6, we're sending it via XR4 and XR6, 5. And so this would be the low latency path in this case. So let's take a look at the config first. So the config is quite easy. So you define the client IPv6 address. So this is the address of host A. You want to tell the client application where the Hawkeye controller is reachable. In our case, the Container Lab management IP address. And importantly, you have different services. In this case, we want to connect to host B, where the web server B is connected to. And we want to mention only encapsulate HTTP traffic running on port 80 with the intent low latency. That's it. So we can start the application. So actually, I forgot to start the controller. I start it now. And then we have almost immediately a result, since we're using gRPC RPCs, which are very, very fast. And now we can test it. So we can connect on port 80 again to the simulated web server. We can exchange messages. And then we can take a look at the packets in Wireshark. And we will see now we have the segment router header attached. And so the packets in this case are going through the intended path from XR1 to 2, then to 4 to 5, so avoiding this huge delayed link, and then to the web server B via the host 6. If you again check the whole connection, we will observe that now the delay dropped to around about 20 milliseconds. This is because we are avoiding this huge delay link. Yeah, so this was it from a demo perspective, and I'm already at the conclusion. So with IBN plus SRv6, we give the end user the ability to influence traffic. And we think this is a very easy way to, which uses less or no configuration at all, just like this. You have your initial SRv6 network or IPv6 network, and then you have this config. You do traffic steering on an application level. So I think this is very powerful. And I think this is a solid foundation for future projects, especially for us in research, but also we got some requests from the industry side for some use cases. I think with that, we're going a step closer to simplify network management and enhance the operational agility. With that, I'm already at the end of my presentation. If there are any questions, I'm willing to answer them. Thank you.
Vincent from Free. You are using up-by-up routing, and you are using not microseed. So I think you may hit the limitation on many routers that are not able to process this big SOH header. Yeah,
so we try to find like the easiest way to do that, right? So this is why right now we're using full seeds. We're using an SRh, which can be a problem. This is true. But we also tried or thought about that, how we can improve that. For example, using compressed seeds, so micro seeds. But there we have the problem right now. We are using just the reverse seed for the traffic back from server to client, which is not working, since with micro seed especially, you're removing the information, right? And so next step would be that we're using compressed seed with micro seeds. But then we're using probably a destination option header to encapsulate the path back, right? So the server can take the information, the destination option header, take the information out, and knows on which path back it has to send the traffic so that the intent is fulfilled all the time.
Okay, you could also just put, on your example, you could optimize by putting only one node in the SRh too.
So yeah, so the other thing, you could optimize it. Probably you could use like a special flex algo, which have like kind of this, but just with one. Oh, you meaning by the low latency intent?
Yes, not just not using a flex algo. You could just target to say go to XR5 and use the IGP, and
yeah,
the IGP will follow XR2, XR4 just to reach XR5, and from XR5 it will.
Now I get your question. This is absolutely correct. So we're using, in our case, we're using each static SID to send it hop by hop. But you're right, you can optimize that. Either you can just find like the shortest IGP metric as long as it's the same path as the low latency path. This would be possible. But even I think with a own flex algorithm, this could be improved. That we probably bring it down to one segment. So this would be an improvement. Yes, it's not implemented yet.
Let's talk after.
Yeah. No. So I'm aware of that.
Hi, Martin from Swisscom. How do you feed the metrics back to the orchestrator, so the link delay or the packet loss?
So I'm too far. So you're talking about how I get like the latency and everything. So we are using streaming telemetry, Yang push in our case with sys. Where we can, we're using open config models, but there are not all the information available. So you'll be using, in our case, Cisco model driven, so the vendor models. Since we are deploying that on a container lab, I had to build my own service so that I can integrate the delays I can set in the container lab to fill like the streaming telemetry messages from the router, since they are empty, since we don't have performance measurement, we don't have P2P synchronization. But actually, you could use that with hardware, and it works exactly the same. Since we're using all the standardized fields and standardized methods, so you would also get that from hardware in exact the same form. This is what we ensured.
Okay. So. We've run out of questions, and we have one, but quick.
Yeah, sorry, it's because of the PowerPoint sync issues.
Benjamin from Bigte. What happens if the IBS system does not respond? Is there a mechanism like to fall back with basic routing, classic routing?
Yeah, so we implemented our system that the fallback, so we decided the fallback is just the shortest IGP metric. I think also, maybe to tell you a little bit more information about that, I think for specific use cases, it's a fit for specific use cases, but probably not for all the traffic. So if your IBS traffic, if your IBS system or IBS goes down, you should ensure that it's not like high critical traffic, which still is okay to go through the shortest IGP path.
Thank you.
Okay, thank you very much.
Thank you.
Thank you.